What if I told you that someone alive today could visit another galaxy before they die? Not in a science fiction movie, not in a dream, but actually travel 2.5 million light years to Andromeda and come back to tell the story. Sound impossible? It is. According to everything we know about physics, according to Einstein, according to every scientist who's ever looked up at the night sky and done the math. But here's the thing that'll blow your mind. There's a loophole, a strange, beautiful, mind-bending quirk in the fabric of space-time itself that could make the impossible possible. And it doesn't require magic. It doesn't require breaking the laws of physics. It just requires understanding them better than we do right now. Let me show you how we could reach another galaxy in a single human lifetime, and why this might not be as crazy as it sounds. The impossible distance. First, let's understand just how insanely far we're talking about. The Andromeda Galaxy is 2.5 million light years away. That means light, traveling at 186,000 miles per second, takes 2.5 million years to get there. To put that in perspective, the light we see from Andromeda right now left that galaxy before humans existed. Before Homo sapiens walked the Earth. Before our ancestors even knew how to make fire. That's not a distance. That's an abyss. A void so vast it makes interstellar travel look like a walk across the street. With our current fastest spacecraft, it would take over 60 billion years to reach Andromeda. That's 4 times longer than the universe has existed. The sun would burn out. It would explode into a white dwarf. The solar system would be long dead before we got even 1% of the way there. So yeah, intergalactic travel is impossible. Case closed, right? Not quite. Because there's something most people don't understand about space travel at extreme speeds. Something that changes everything. The time dilation miracle. Here's where it gets weird. According to Einstein's theory of relativity, time is not absolute. It's flexible. It bends. It stretches. And the faster you move, the slower time passes for you relative to the rest of the universe. This isn't theory. This isn't speculation. This is proven, observed, documented reality. Astronauts on the International Space Station age slightly slower than people on Earth. GPS satellites have to account for time dilation or they give you directions to the wrong location. This is real. But here's the part that matters for intergalactic travel. The closer you get to the speed of light, the more extreme time dilation becomes. And I mean extreme. Let me give you an example. If you're traveling at 99.9% the speed of light, time slows down by a factor of about 22. 1 year for you equals 22 years for everyone else. You age 1 year. The universe ages 22. But we can go further. At 99.99% the speed of light, time slows down by a factor of 70. At 99.999%, it's over 200. At 99.9999%, over 700. You see where this is going? The closer you get to light speed, the more compressed time becomes from your perspective. And theoretically, if you could get close enough to the speed of light, you could travel across the entire universe in what feels like days or weeks. From your perspective, inside the ship, Andromeda isn't 2.5 million light years away. It's a few months, maybe a few years. A single human lifetime. That's the loophole. That's the miracle hiding in Einstein's equations. You can't break the speed of light, but you can cheat time itself. The propulsion problem. Okay, so time dilation makes the journey possible in theory. But how do we actually get to those speeds? How do we accelerate a spacecraft to 99.9999% the speed of light? This is where things get really challenging. Because the amount of energy required is astronomical. Literally. Let's say we want to send a small probe, something the size of a car, to Andromeda at near light speed. Using conventional rocket fuel, you'd need more energy than the sun produces in a year. Using nuclear fusion, you'd need to carry so much fuel that the ship would be the size of a small planet. It's not practical. It's not even possible. So we need something better. Something revolutionary. And scientists have a few ideas. Crazy ideas. But ideas that might actually work. The Antimatter Engine. The first option is antimatter. When matter and antimatter collide, they annihilate each other completely. 100% conversion of mass into energy. No waste, no byproducts, just pure, explosive power. 1 kilogram of antimatter reacting with 1 kilogram of matter releases as much energy as a 43 megaton nuclear bomb. That's the largest nuclear weapon ever tested, times 2. From just 2 kilograms of fuel. An antimatter engine could theoretically accelerate a spacecraft to a significant fraction of light speed. Maybe 20, 30, even 50% if we're optimistic. With time dilation at those speeds, a trip to Andromeda might take tens of thousands of years from Earth's perspective, but only hundreds or thousands from the crew's perspective. Still not quite one lifetime. But we're getting closer. The problem? We can't make antimatter in useful quantities. CERN, the world's most powerful particle accelerator, produces about 1 nanogram of antimatter per year. At that rate, it would take billions of years to produce enough antimatter for a single interstellar voyage. But technology improves. Maybe in 50 years, maybe in 100, we'll figure out how to mass-produce antimatter. And when we do, the galaxy becomes accessible. Maybe even other galaxies. But there's an even crazier idea. One that doesn't require any fuel at all. The Lightsail Revolution. Imagine a sail. Not a cloth sail on a boat. A massive, ultra-thin reflective sail attached to a spacecraft. Miles wide, weighing almost nothing. And instead of wind, it catches light. Photons from a laser, or even from the sun, hit the sail and transfer momentum. Tiny amounts of momentum per photon. But billions and billions of photons add up. Over time, the spacecraft accelerates. Faster and faster. No fuel required. No engines. Just light. This isn't science fiction. We've already tested this technology. The Planetary Society's Lightsail 2 successfully demonstrated solar sailing in Earth orbit. It worked. It actually worked. Now scale that up. Imagine a laser array on the moon or in orbit around Earth. Thousands of powerful lasers all focused on a single light sail, pushing a tiny probe up to relativistic speeds. 20% the speed of light. Maybe more. At 20% light speed, time dilation kicks in. The trip to Andromeda, which should take 12.5 million years, might feel like 10 million years to the probe. Okay, that's still not one lifetime. But we're talking about existing technology. Stuff we could build in the next 50 years. And here's the beautiful part. Once that light sail is up to speed, it doesn't need any more energy. It just coasts, forever, across the void between galaxies. Silent, weightless, eternal. But if we really want to reach another galaxy in one human lifetime, we need to think bigger. We need to think impossible. The Alcubierre warp drive. In 1994, a physicist named Miguel Alcubierre published a paper that changed everything. He proposed a way to travel faster than light without actually moving faster than light. Sound like nonsense? It's not. It's brilliant. Here's how it works. Instead of moving through space, you move space itself. You contract the space in front of your ship and expand the space behind it. The ship rides inside a bubble of normal space-time, never actually accelerating. But from the outside, the bubble moves faster than light. The ship surfs on a wave of space-time distortion. Nothing in Einstein's relativity forbids this. You're not moving faster than light. Space is. And space can do whatever it wants. It expanded faster than light during the Big Bang. It's still expanding faster than light at the edges of the observable universe. If we could create an Alcubierre bubble, we could travel to Andromeda in days. Maybe hours. From your perspective and from Earth's perspective. No time dilation. No waiting. Just instant travel across the cosmos. This is the Holy Grail. This is the dream. Warp drive. Star Trek made real. But there's a catch. There's always a catch. The energy nightmare. To create an Alcubierre bubble, you need negative energy. Not just a little bit. A lot. More negative energy than exists in the visible universe. What's negative energy? It's not antimatter. It's something even stranger. It's a region of space with less energy than empty space. A vacuum with less than nothing inside it. And we've actually observed this. It's called the Casimir effect. Put two metal plates incredibly close together in a vacuum, and the quantum fluctuations between them are suppressed. The space between the plates has negative energy. We can measure it. We can prove it exists. But the amount we can create is microscopic. Nowhere near enough to warp spacetime. You'd need the energy equivalent of the entire mass of Jupiter. Negative. Just to create a bubble large enough for a tiny probe. That's not happening anytime soon. Maybe not ever. Most physicists think the Alcubierre drive is mathematically possible but practically impossible. A beautiful idea that will never leave the pages of scientific journals. But here's the thing. Every single breakthrough in human history was impossible until it wasn't. Flight was impossible. Splitting the atom was impossible. Going to the moon was impossible. Until we did it. And scientists haven't given up. They're working on modified versions of the Alcubierre drive that require less energy. They're exploring other exotic propulsion concepts. Wormholes. Quantum tunneling. Space folding. We don't know what's possible yet. We're still learning. Still exploring. And that's the point. The generation ship alternative. Let's say we can't crack faster than light travel in our lifetimes. Let's say warp drives and antimatter engines remain science fiction. There's still a way to reach another galaxy. It just requires sacrifice. The generation ship. A massive, self-sustaining spacecraft capable of supporting thousands of people for millions of years. A flying civilization. A city in the stars. You wouldn't reach Andromeda in your lifetime. Neither would your children. Or their children. Or their children's children for 10,000 generations. But eventually, someone would. Your descendants would step foot on an alien galaxy. And it would all be because you made the choice to leave. Is that worth it? Would you board a ship knowing you'd never see the destination? Knowing your entire life would be spent in transit, raising children who'd inherit the same fate? Some people would. I know they would. Because humans have always been explorers. We've always looked at the horizon and wondered what's beyond it. And some of us are willing to sacrifice everything to find out. But there's another option. One that's even more radical. One that might actually let you reach Andromeda in your lifetime without traveling at light speed. The suspended animation Gambit. What if we could just turn you off? Put you in a state of suspended animation where your body doesn't age. Where time passes but you don't experience it. And then wake you up when you arrive. This isn't as far-fetched as it sounds. We already do something similar with medical cryopreservation. We can freeze embryos for decades and successfully implant them. We can slow down the metabolic processes of organs to preserve them for transplant. We're not at the point where we can freeze an entire human, keep them frozen for millions of years, and wake them up healthy. But we're working on it. And every year we get closer. Imagine this. You board a ship to Andromeda. The engines fire. You accelerate to 1% the speed of light. Not fast enough for time dilation to help, but fast enough to make progress. Then you're put into suspended animation. Frozen. Time-locked. 250 million years pass. The ship coasts through the void. Silent. Lifeless. And then finally it arrives. The computers wake you up. You open your eyes. And outside the window is another galaxy. From your perspective, no time passed at all. You went to sleep in the Milky Way and woke up in Andromeda. One lifetime. One consciousness. One continuous experience. That's the dream. That's the goal. And it might be possible sooner than you think. Why this matters? You might be wondering, why does this matter? Why do we need to reach other galaxies? We haven't even colonized Mars yet. We haven't explored our own solar system. Why leap to something so impossibly far away? Because we have to think long-term. Because the Milky Way won't be here forever. In about 4 billion years, our galaxy will collide with Andromeda. The two will merge into a new, larger galaxy. It'll be beautiful, violent, and potentially catastrophic for any life still living here. But even before that, the sun will die. In 5 billion years, it'll expand into a red giant and swallow the Earth. If humanity is still confined to this solar system, we're done. Extinct. And even if we spread across the Milky Way, colonizing thousands of star systems, we're still vulnerable. Gamma ray bursts, supernovas, black holes, the eventual heat death of the universe. If we want humanity to survive forever, truly forever, we need to become an intergalactic species. We need to spread beyond the Milky Way, beyond the local group, beyond everything. Intergalactic travel isn't about curiosity. It's about survival. It's about ensuring that billions of years from now, when the last star in our galaxy flickers and dies, there's still a light burning somewhere in the cosmos. A light that carries the legacy of Earth, of humanity, of everything we ever were. The first person to reach another galaxy. Here's something that keeps me up at night. Somewhere, right now, a child is being born who might be the first human to reach another galaxy. They don't know it yet. They're just a baby, crying, learning to walk, going to school. But if we invest in the right technologies, if we push forward with antimatter engines, light sails, suspended animation, maybe even warp drives, if we don't give up, if we keep exploring, that child could grow up, board a ship, and leave the Milky Way behind. They'd be a hero, a legend, the first intergalactic traveler in human history. Their name would be remembered for as long as humanity exists. Longer than any king, any president, any conqueror. And maybe that person is watching this video right now. Maybe it's you. Maybe you're the one who'll take that first step into the cosmic unknown. The one who'll prove that no distance is too far. No dream is too big. Wouldn't that be something? Closing. So why could intergalactic travel become reality in one lifetime? Because the universe gave us a loophole. Time dilation. Because humans are stubborn and creative and refuse to accept the word impossible. And because we have to. Because the survival of our species depends on it. We won't get there tomorrow. Maybe not in 50 years. Maybe not in 100. But the seeds are being planted now. The research is happening. The technology is being developed. And one day, maybe sooner than we think, someone will board a ship and leave the Milky Way behind. Will they come back? Will they ever see Earth again? Probably not. The distances are too vast. The time scales too extreme. But they'll carry a piece of Earth with them. A piece of humanity. A piece of everyone who ever looked up at the stars and wondered. And that's enough. That's everything. If this inspired you, hit that like button. Subscribe to join us as we explore the wildest possibilities of space travel and humanity's future. And tell me in the comments, would you take a one-way trip to another galaxy? Would you leave everything behind for a chance to see something no human has ever seen? I'll see you in the next one. Until then, keep dreaming big. Keep looking up. And remember, the universe is waiting.